So the summary is, this is basically what you can do. You can do a surface analysis, the quick and dirty, tell me what the files are, tell me what's in the file. Do I see anything there that catches my attention? Like an IP address, like a host name, like a URL, like credentials. And if not, and then if it catches my eye, then I have a clue what's going on. I can then do a runtime analysis. If that doesn't give me anything, let me actually run this thing and see if I can put it in an environment where it'll act the way that it's going to act, whatever that means. That's hard to do. It may take a lot of steps to figure out where it's going to need to run to do its thing. And then finally, I can do a static analysis where I can actually go back and look at the code. Have any of you done malware analysis? So did you do these kinds of things? Did you actually reverse it?
Yeah. But it was never packed.
Okay.
Yeah.
Well, that's just one layer. You know, if they happen to use a standard packer, then that just makes it a little harder. So this is as gives you a clue as to what happens. You know, if you unpack it and it's antivirus, then you run the file command on it. Maybe you run the strings on it. Maybe there's some other. You can do some cryptographic hashing. Then you can run it. Let the sysinternal tools have at it. Look at network monitoring. Unpack it and do some reverse engineering. So this gives you some clues as to what you do from this point forward. And then the various phases of surface, runtime, and static. So surface may give you enough if what you're looking at is in the clear, in essence, or in the clear once you've unpacked it. Runtime analysis, a little harder to do, hard to set up the conditions to make it do its thing. Static analysis is the hardest of all of them. And so this then gets into reverse engineering and what it means to actually take that binary back into, in essence, the code that you're trying to get to. And it is an art. Takes a lot of time to learn how to do this. I have not ever tried this. The challenge with artifact analysis then are the resources it takes to do this, which means computers, which means time and effort, the facilities, processing, and then the dissemination of knowledge. Once you reverse engineer, who do you tell? And what do you tell them, and how do you tell them to deal with it? So this is not for the faint of heart. Again, it's a thing that's procedure-driven for how you enter artifacts into the system, what you do with them from that point. And one of the things I learned early on when we were doing vulnerability analysis as CERT is we didn't save enough of the right kind of information initially to be able to mine it for information later. For example, what I'm saying in that is if we had taken the time to try to actually find the bad code that led to the vulnerabilities, then we could take all those examples of bad code and write a good coding practice guide. Unfortunately, what we did not do in the early days of CERT was to capture the artifacts of bad code. The person did this. They used string copy. The person did this kind of an operation. So since we didn't save that, we didn't have that. What we did learn in artifact analysis was some notion of how we wanted to use the information we gleaned. So that we came up with a scheme for cataloging the artifacts, which can be very helpful because then we could mine that catalog to learn things from it. That was the intent. If you don't do artifact analysis, maybe you can contract it out. CERT does artifact analysis. Other people do artifact analysis. So if you don't do it, somebody else can do it for you.
Is it like centralized database tools and artifacts? Because I mean, every new virus coming out, so each company, McAfee gives it one name, Norton gives it another name. So that means there's no cooperation between them.
I understand the question, and I honestly don't know the answer. A lot of people use us, so we have developed a standard, and I don't know how many stuff is in the artifact catalog, but I'm thinking it's in the millions. So it may be that whatever our standard is for our customer base has standardized that. But yes, I understand the various AV vendors go in their own direction.
Their website's set up to compile all the different vendors' output.
You mean like total virus?
Virus total.
Virus total.
Okay. So building a test infrastructure, as I've said, is again not for the faint of heart. It takes a while to do it. It takes a while to get it right. And you constantly have to, you're putting bad code in this environment, and it's doing things. And so you need to be able to rebuild that test environment quickly after bad things have happened, which is what viruses typically do, malware typically does. Bunch of stuff. You may have multiple analysts at the same time, different versions of operating systems, different configurations, essentially, and then rebuild it somewhat at a moment's notice. And then how you use it. This is very procedure-oriented. I want to go back to a known state. I want to run this piece of malware in there. I want to know what it does. How do I get back to that known state for repeatability? So that, because if you're doing artifact analysis and your results are not repeatable, then it's somewhat useless environment. So repeatability becomes important. It's not easy. Lots of artifacts. We get many of them inside the forensics team frequently, which we run through our quick analysis stuff, which is Micarta. And so there's more all the time. So that's kind of a quick and dirty on artifact analysis and what would happen at this point. What?
Oh, I just wanted to add something. Okay. So as Larry was saying, with the more complex side, the reverse engineering piece, and how that's really an art form. And so we've got folks in the malicious code team who've been doing this for years and years and years. And it's really takes a while to get intuitive about it. So, for example, if you look back on page 62 of this presentation, where there was that packed versus unpacked strings, some of the folks, because of the fact that they were doing it so long, they get a feel for certain things. So little things will stand out. May not seem important to you, but someone who's used to this can look at something like this just from the strings, and meow stands out to them as actually a signature for something else. So they get to be extremely intuitive about it. But to get someone to that level, they have to be doing it many years. They have to be working as an apprentice with someone for many years. So one of the things that CERT's looking at now is how do you rapidly scale that up? With, as Larry said in that last slide, with more and more artifacts out there, with analysis, there's a lot of automated tools, but to get full functionality at a reverse engineering level, if you have to go to that level, how do you scale that up? And so we're actually looking at a project to document a taxonomy. There's no standard taxonomy for malware analysis, and to just start so everyone can start at a same place. And we're looking at we're actually looking at, can we do what's called an ethnographic study, which is to actually sit with the folks who are these experts who have been doing this for over 10 years, and what do they know and what do they do that they would never even think about. If they were trying to teach you how to do it, it would never even occur to them to tell you this, because they just do it. To see, can we make that more than just like, 10 years and you become a guru. Right. How do we scale it up? So I find that very interesting, and that's something that CERT's looking into now.
And that's one of the things that I proposed with respect to forensics. There are the investigative questions that you ask about a system. And as an investigator, you want to know the answers to those questions, but you don't need to know. I don't think you need to know all the specifics about the underlying environment. If I want to know that these two people talk to themselves, I don't care that they used Office, that they used Outlook under Windows 7. I want to know that they talked to themselves, that they talked to each other, or that they chatted via instant messenger. So why do I have to take 10 years to scale up a forensics analyst? Can I have an investigator ask investigative questions of the same pieces of evidence and get investigative answers without having to take 6 to 12 months to do an investigation? Comparable thing. How do we spin them up? How do we make forensics for the masses? How do we do artifact analysis for the masses? Same idea. And so we at least have some ideas of directions to go. And I've been talking with some people and considering working with some students, building in a plug-in style architecture where you can take these meta questions and drill down and say, well, if it's this kind of system with this kind of mailer, look in these places to get the answers. And so you can see a tree structure of plugins where at the top level are the investigative questions, and at the bottom level are the techie questions of where I mine the data. And so you can very easily, I think, come up with a system that's extensible as you get more investigative questions, and as technology changes, you can look at more places to get more information. And then I'm an investigator. It's a digital asset, I don't care. I have questions, I ask about it. Same thing with malware. So, comparable ideas. Okay, at this time, we could probably take another break. We have an option at this time. There is we have an extended example of doing some malware analysis that we can sort of do as a group, which I've never done it that way before, but we could do it that way, and walk through it. That's used actually in the advanced incident handling, and we can analyze that malware as a group after a break.